Assalamu alaikum warahmatullahi ta'ala wabarakatuh. Ladies and gentlemen, welcome back to another live stream. Alright. Okay, please join my Discord server. You can find a link in the description, so you can get to, like for example, votes on next streams. You can get notified of next streams. You can also join VC in a stream, so you could talk in live too. Why not? If you have something to say. And yeah, sometimes it gets lonely programming, so welcome to anyone who wants to join in the fun. So anyways, let's see, let me try to let me try to share the stream. Right. Great. Where is I should actually also share with you the Vulkano server, but you could easily find it in the repo. Yeah, anyways, let's go to gonna share with the server too. Off topic, let's go. All right, I think we're ready to go. Let me check the stream quality. Seems stable. Yeah, seems all good. The mic seems on. Yeah, pretty good. So I think we're ready. Okay, so I have managed to actually find out what was my problem. Like in the previous stream, we have implemented MSAA multi-sampling, so it can make the geometry look much smoother. We also tried to work on with GLTF, but like the end of the stream, I was just stuck because it just wasn't working. To be specific, the index buffer was just initialized with random data. So I knew something was wrong, especially that we were using byte cast slice. But yeah, it turns out the issue that I had, or the bug, is just super stupid for my part. Basically, it's just an iterator thing. Essentially here in the vertex buffer view, I have an index buffer view, right? So here I'm getting the views iterator, and then I'm taking the next element. But here I'm taking a new iterator, a new fresh iterator, which means this one is equal to this one because I'm taking the first buffer view in both, so that's why this is happening, because it gives me a new iterator every time instead of just giving me like one iterator, which actually makes sense in this context. So to fix this, it's kind of simple. We just gotta take one iterator, document.views, and then we could say views.next.inwrap. Views, and of course this should be mutable because we need to mutate the iterator. And this should do the trick. The other thing is that I found out how to know the formats of the vertices and stuff. It's through something called accessors. Let me show you. Yeah, so if we go to the crate that we're using, the repo, they have this reference infographic, which is very useful for just very quickly using GLTF instead of having to read the whole spec. At least not yet. So for now, basically what we got here, if we check out here, this is the part that we actually are interested into. The other parts we're just kind of hard coding it for now, but later on we're going to add to implement more stuff into GLTF as we need, basically. But for now, this is what we're interested into: the buffers, the buffer views, and the accessors, basically. So I have figured out buffers and buffer views. It's pretty simple. So like buffers, it's just raw data, pretty much. It could be packed, basically. The buffer views are just like slices, just like Rust slices into those raw buffers. As you can see here, the buffers are just bytes, just raw bytes, nothing crazy. Buffer views actually have an index to indicate which buffer it's talking about, because they could be grouped into multiple buffers basically. So this basically index into the buffer that we are interested into, and then there's a byte offset in that buffer and the byte length, basically a slice, right? And here the byte stride, which is like how much, like how the data, the unit size of that data or something. But anyways, and then the target, and an optional OpenGL buffer target. So this is basically, I think, the enum of the OpenGL type. Like, is it an index buffer or like an array buffer or whatever? And then there's like accessors here. This accessors basically tells you which buffer view it's talking about, essentially which slice of data it's talking about. Like, it's kind of like buffers is just raw data, but here buffer views adds like the type, adds typing to that data, right? But here the accessor gives us even more information about the types and how to access it. So here it tells you which buffer view and the byte offset in that buffer view, another slice kind of, and then the type. Here it's vec2, it's telling you what is it. In this case it's a vector2, and then the component type. The component type is like an enum, OpenGL enum, telling you is it a float or what exactly. And then here you got the count, like how much components, I think. There you go. So here it's 2 because it's a vec2, and then minimum and maximum, nothing crazy there. So yeah, that's basically how it goes. So the buffer data is read from a file, there you go, and then defines a segment of the buffer data, essentially a slice. And then the accessor defines an additional offset, and that's interesting. Maybe I gotta take account of that, but anyways. And the buffer view defines a stride between the elements, and the accessor defined that the elements are 2D float vectors. This is pretty good conclusion from how to use it. Anyways, so yeah, that was the first fix that I had to do. And the second thing, I had to make sure that it's the right format. Currently we're just hard coding it, so what I'm gonna do here is I'm just gonna put a breakpoint. I don't want to implement the whole GLTF just yet to just display a cube. So let's see, if you go to document, I think, and 0 and the accessors, right? We have two accessors. The first one is, if we check the, let's see the count. So in the first one we have eight units of data. And let's see, the buffer view is the first buffer view. And then what else? Where is that thing? Hold on, component type. Yeah, there you go. It also gives us the component type here. It's F32. This is basically the accessor of the vertex position. That's why it's F32. And there's 8 vertex data, 8 unique vertices basically. And then what else? There's also the second accessor counts is 36, which means we have 36 units of data. And where is the target though? Type is scalar. Okay, and what else? Component type, it's U16. So in this case, the index type is U16, not U32. Which makes total sense. And then here we got the buffer view. Anyways, so I just gotta make sure that my index data right now is using U16 instead of U32. And okay, and by the way, hold on a second, if anyone wants to talk in VC in Discord, let me know. VC, okay. So if anyone wants to, let me know. Anyways, what else right now we gotta do? Yeah, gotta make sure that it's U16. So U32, we're gonna replace it with U16. So replace. Okay, replace. I don't know how to like alias a type, but in Rust just yet. So we're just doing it this weird way for now. Anyways, so this should actually work right now because we fixed the iterator bug and we have fixed the indices. We have made sure that it's the right vertex. Right now we're actually seeing a cube. But I guess maybe we're inside the cube, right? So let's actually go to render doc and see what's really happening. If we go to render doc right now, let's see, and let's try to launch the application. Oh my god, I can't, like, come on, save the path. I have to give it the path every single damn time. Anyways, let's see, open in dolphin, blah blah, and even this IDE doesn't really give me an easy way to copy the path, damn it. Anyways, executable path, and let's go with this, and let's launch it, I think. Alright, and let's capture some frame, and let's see what is really happening. Okay, so if we go to pipeline stage, the mesh view, and let's make sure we are in the right place here. There you go. Okay, great. Okay, so this is the vertex output that we're getting right now. Like, seems like all the vertices are in the same place. It's weird. Perspective, but this is the vertex input, which means it's correct. Though I'm not sure why it's given only one triangle. It should be two, but yeah, there you go. Pretty cool. So right now what we're gonna need next to actually see a cube is a camera, 3D camera. So we need to figure out the matrices and stuff. So yeah, let's go ahead and do that basically right now. So now I have a choice to do, and wa alaikum assalam, welcome to the live stream. How's it going? So right now what I gotta do is figure out how to give, like, to deal with matrices like model, view, and projection matrix stuff to actually see 3D objects, right? And now we have some choice to do. The choice is either to implement the math yourself, which is pretty boring, or to use a library. And now even to use a library, have a lot of choices, though the main choices that I know of, at least in terms of Rust, is there is some crates, and I've already chosen one, but like the first one that you would probably want to go with is Glam, if you want just a simple library that would just do the job, right? The other thing would be NAlgebra. Now, I honestly used Glam before, but I'd like to use this time NAlgebra and try it. I'm gonna try it live with you. Why I want to use NAlgebra? Because it contains a lot of crazy operations that I may need at some point. That's the first thing. Second thing, because I'm probably gonna be using a physics engine, and that physics engine is called Rapier. So like Rapier physics engine. It's of course a Rust library. It's basically multi-platform physics simulations. It contains cross-platform determinism if you want to do networking and stuff, and all sorts of cool stuff, right? That's pretty good. I think it's very much the best in the Rust ecosystem. And yeah, later on I may want to use this. So, and this guy right here, if we go to the documentation, in fact, this physics engine is made by DimForge, right? And the thing is, NAlgebra is also made by DimForge. And if we go here to the documentation, this crate actually exports NAlgebra. There you go, pub extern crate, which means that this Rapier 3D library, if I add it later on, it would pull on this dependency. So since it's gonna use this library anyways, so why not just use it myself, so we don't have to like have multiple math libraries, and it's like just reusing the same library would be pretty nice. Okay, so that's why I'd like to actually, at least for my own preference, I'd like to use NAlgebra. So let's try it out and see if it actually works out for us or not. Though it's pretty heavy on algebra, it contains more than what you would even need, but anyways, so let's go ahead and add an algebra right now, I think, and let's see what we could do. So cargo add in algebra. So cargo add in algebra. Is there any interesting features? Let's see. We probably want to add a byte mock feature though. SIMD is enabled debug render. That's interesting. Rayon for parallelism. Okay, but where is one feature? Byte mock. I do remember there was a byte mock feature. Where is it? Well, that's super weird. But anyways, let's add a feature called byte mock because we're gonna need it to actually use it in our vertices data. So, or not vertices, uniforms, right? So dash features byte mock. And as you can see, we added the byte mock feature, and there's 55 deactivated features. I'm not sure why it's not showing all of them here. I'm really not sure. Anyways, whatever. So that's pretty much it to add the in algebra library. Let's just compile this real quick. And we're gonna figure out where to start with this. I'm gonna pull in the Vulkano example for uniforms just as a reference here. To make sure I'm doing everything correctly and I don't miss anything. Let's see. Okay, Vulkano examples. Let's see. I'm not sure if they have some example for uniforms specifically. I don't think, but we could go with the cheapo example maybe. So yeah, alright. Yeah, they don't have that, so I guess I'm gonna go with the cheapo example and take inspiration from that. Okay, so I think we're gonna need like a uniform buffer right now. Yeah, there you go, uniform buffer. It's gonna be preferred. Like, let me actually show you. Let me show you. So this is the teapot example. It basically draws a teapot. And you can notice that they're making a uniform buffer here. They're making it in the device and host sequential write. Interesting. Weird combination, but okay. Render pass, depth stencil. Yeah, we're gonna need depth at some point. You're gonna see why later on, but for now, let's just go with it. And also another thing that I missed is that I want to get the camera properties from the GLTF itself, because GLTF actually isn't just for meshes. It actually describes the whole scene, you know. So like you could get the, like you could put the camera in Blender, let's say, and just import it from there. And I think that's probably what I'm gonna go with. There you go. So each scene could have multiple cameras, I believe, and stuff like that. So let's actually go to Blender real quick. Let's go to Blender and let's add a camera to our scene first. So general, I should have actually saved my previous scene, but anyways, so I'm not gonna need light for now, I think, but let's just leave it because I'm gonna need that later on pretty soon for lighting calculators. So yeah, let's just leave that. Here there is a collection though. Can I just get rid of that collection? I don't need that stuff. Yes, so here we're gonna have our camera. How do I preview a camera in Super Noob at Blender? I don't remember. View maybe? View regions, cameras. Ooh, really don't remember how would you do it. Anyone have any idea? Let's see. Align view. Align active. Nah. Align view to active. Huh. Align view to active. Center view to cursor. Bruh. How do you align a camera in Blender? Align camera to view or align camera. line view to camera, Blender. Let's see real quick. To view and fit the view. So view, cameras. First hit numpad to enter camera view, then press home so the camera fills the window. Numpad 0, okay. Alright, let's go. So 0 and what else? Home. Let's see, home, where is home? I never used the key before. I have no idea where's home. I guess this is it? Yeah, I guess so. Interesting. There you go. Okay, so this is what our application would basically see, which is nice. So let's go ahead and try to actually export this right now. So let's try to export it as GLTF. For now, I'm just going with GLTF embedded, just for simplicity. Later on, though, I'm probably gonna go GLTF separate. But anyways, let's see. Let me make sure that I'm not adding anything that I don't need for now. Mesh materials. I don't really need materials currently, I think. Only know what may be fine. Yeah, no, let's keep it simple for now. Let's not have any materials on. No UVs for now. I'm probably gonna need the normals, but anyway, for now it's fine. Vertex colors for now, no. And no shape keys, no scaling, no animation for now. So yeah, include custom properties, include cameras, right? Correct. Include punctual lights, export directional point and spotlights. Oh, it uses an extension. Interesting. Well, for now, let's just export the camera only, is the one that I'm interested into for now. And yeah, that's pretty much it, I think. Let's try to export this now. I'm gonna export it directly into my project, so I don't have to keep on creating new projects and stuff. Let's see. So where I put in my projects, I think in C, in, what is it called? Rust Rover? There you go. Probably this one. Vulkano, right, assets, cube.gltf. There you go. And let's export it there. Later on, we may even like to kind of like use Blender, exploit Blender as an editor for a thing. For example, just like how Godot does it, let's say like you just save a Blender file and then it would like watch over the Blender file. If it gets changed, then it would call into Blender using command line to export to GLTF and then import the GLTF, so you don't have to keep on like compiling the projects and stuff. We could even exploit GLTF custom properties to add things like collision, like to hint to the application that we want. Let's say this cube, we want it to have a physics body with a collision box or something like that. But we'll see. There's a lot of cool things that we could do. But anyway, for now, let me just try to save it though. Import, export, so I don't lose it. Let's go, and I'm gonna save in the same project actually. Where is Rust Rover? Volcanox assets, and let's just save it here for now. Cube.blend, whatever, or you know it. Yeah, fine. Anyways, and I'm just gonna save it there. Anyway, I don't really need it in my application, but just to keep it there when I need it. So anyways, so right now we got our cube.gltf. It contains, as you can see, a scene, and it contains two nodes, a camera and also a cube mesh. Basically, the camera have the translation baked in and the rotation baked in, which is nice. What about the matrices? There you go. Okay. And in cameras, you gotta have like the perspective. This is also we're gonna need the Z-near, the Z-far. There you go. And we got the FOV basically. Oh, the Y FOV. Why it's yeah, I guess maybe it's in not in angles. I think it's in radians maybe. So aspect ratio, there you go. Though the aspect ratio, we're gonna actually get it from our window. I mean, we don't need the aspect ratio here, I guess. Anyways, whatever. So what else? Primitives, position, and indices 1. I think it's basically the same thing. Buffer view 0, accessors, count vec 3, count scalar, component type. Yeah, honestly, it's better to... Yeah, let's see if our hard-coded GLTF still works by any chance. Okay, it still works just fine, which is lovely. Okay, right now let's actually extract first of all the camera stuff from our GLTF, and let's see how we can do this. Where we're loading the GLTF, there you go. Okay, great. Let's see. So we're gonna access the, let's see, the camera data or whatever, and let's maybe call as documents dot. Can we access cameras? There you go. That visits the cameras of the GLTF asset, and then we could like go ahead and get the first camera, and then unwrap it. I think. Well, we could just do this. And yeah, that should do the trick. And this gives us a GLTF camera. What this contains, this contains the projection. Nice. What else? And it contains an index. Yeah, it contains also an index. Now I would guess this index into something else. So where's indexing? Not sure. Maybe in the scene or something. Like if we go to scenes and let me try to see this. Hold on. Let me see what I could do with this. Let camera data use okay or what? Oh, I see. The error isn't for some reason compatible. Anyways, that's super annoying, but whatever. So let's unwrap that, and let's see what we got. Okay, so let's see. Camera data, and it contains the reference to the GLTF document. Okay, then some JSON stuff too. We probably don't want to access that, maybe. And 0 accessors, images, animations. So for the camera, there's two things. There's this guy right here, which does indeed contain the perspective here. So I think we got the perspective already. What we need right now is the translation of the camera, and I guess we can take that from the node. Yeah, I think so. Yep, from the node. And in this case, why we have two nodes here? We got a camera. Yeah, well, we got two nodes. Yeah, I think the mesh is the cube, right? Yeah, the cube. So we got the two nodes, one for the cube. And yeah, we're gonna need that to actually take the matrix, the model matrix, isn't it? Why there's no model matrix in translation? Interesting. Anyways, who cares? Let's go with the matrix of the... What? The camera doesn't contain a matrix? Why? Well, at least it does contain the translation. And yeah, and the rotation as a quaternion though. Interesting. And yeah, that's all we need pretty much. So we gotta go to the first node. Currently we're just hard coding stuff. So the first node, and we're gonna go to the camera. Actually, not the camera is not what we need here. Well, we do need the camera, right? And then the rotation, and finally the translation. Okay. So let's try to do this. Let's see. So instead of camera data, so let's go with document dot nodes dot. So I guess, well, I think it's the first node, right? I think so. Though, just to make sure, we're gonna make sure that this is correct. Let's see. Okay, great. And let's see where we got camera data, or camera node, should I say. And name camera. Okay, great. So this is the camera node, basically. Now let's figure out how we could actually get a camera from it, basically. Okay, we could do this. Returns the camera referenced by this node. And we could probably also take the transform. Interesting. Okay, what if we get the camera? What this would give us? We could unwrap it, because it could be okay. And then what we should do, index project. Okay, here we could actually get the projection. All right. So first, let's get the camera projection. Why not? So it's basically, and actually, let me just say unwrap.camera, pretty much .unwrap again. So yeah, and then after that, why does it still node though? Oh, there you go, it's got updated right now. So let's get the camera projection first, I think. Actually, no, I don't want this here. Let's do it here. Oops. That's the camera projection. Next up, we're gonna need the camera transform, I think. Hopefully this would work. Let's see, camera node dot transform. And yeah, this should probably work out just fine. Let's see. Though I think it's a good idea to use some program like, for example, Blender here in GLTF to base your implementation on, because you can make sure that what you're doing is correct. But yeah, anyways, let's see. So here we got the camera projection, right? It's perspective, and the camera transform, which contains the translation and the rotation and the scale, which is just okay. Lovely. Though I still need some other thing here, probably. Maybe not. Clone. How do I get the actual? Yeah. How do you actually get the data of the projection out of this? Weird. Well, I guess I gotta check the documentation of GLTF for that. But for the camera transform, at least, let's see, we could get a matrix out of it, which is nice, or decomposed, which would give us the translation, the rotation, and stuff like that. Pretty cool. Okay. Now I think let's try to create, but hold on, how do I get the camera projection? Oh, it's an enum. Interesting. So it could be like an orthographic or perspective. How do I get it if it's perspective? I mean, I know the way to do it. Like, I guess you could just say this, match projection, and if it's like what is it called again? If it's JSON camera type orthographic and stuff like that. There's no helper function there, but anyways. Alright, let's just do this. Orthographic do something. unresolved reference import. Okay, what's up with this? I found type. Yeah, no, I'm super confused. Hold on. Where is this projection? It's inside camera. Projection, perspective, let's say. Okay, let's see. And otherwise, just ignore it for now, I guess. Maybe we could do something else. Anyway, let's see what we got now. Okay, great. Now we're gonna get the perspective. Okay. Now here we can actually access that stuff, right? So aspect ratio of the field of view, z far, y far. Okay, lovely. Now let's go to the NLGBR documentation. And I believe they had some good manual right there. Maybe docs, user guide. Let's go. Nice. Computer graphics recipes. Let's go. Okay, nice. So like from the get-go, you're gonna notice that this is more sophisticated than your average GLM library. It contains, for example, isometries. It contains all sorts of weird stuff. But yeah. Anyways, so what I want right now, I want the perspective stuff, projections, right? So orthographic projection, and here's how you do it. Arguments order, left, right, z near, perspective projection, let's go. And this is how you do it basically. Well, I just want this. And for now, I'm just gonna panic or implement it if this doesn't exist, because we're not implementing this just yet. Import. And yeah, with this we get the perspective of the camera, or the camera projection. Great. But the aspect ratio, this would actually change depending on the, I think, depending on the width and height, right? So we gotta say, we gotta make sure to do I have the swap chain stuff right now? I don't. Yeah, this would depend on the, yeah, makes sense, right? So we gotta actually do this in the Vulkan renderer instead of the device right now. So the camera node. Yeah, pretty much. We gotta do this in the renderer. So camera transform, camera node. Let's see. Yeah, we're gonna pass in the camera node to the renderers, and then they could like make their own camera projection matrix. So in camera transform stuff. Anyways, so let's go ahead and actually just save the camera node here. How do I do that? It's a jumbled up mess, but later on we could clean it up. So here let's just say camera node, and here it's gonna be a GLTF node, I think. And missing lifetime specifier. Damn, I don't want to deal with lifetimes, bro. No way. I'm not going there. I'm not falling for that trap. Damn it. Let's see. No way. Let's go with camera. Damn it. Let's see. Perspective, new FOV aspect, blah blah blah. So yeah, I guess we could pass in the projection of the camera. Yes, the camera projection, and then the camera transform. Separated for now. So camera projection. And come on, really? What? Are you kidding me? No way. This is super stupid. Like, why the projection have to have a lifetime? That's super stupid. Anyways, whatever. So okay. Well, for now, let's just do it the way that we were doing it, and we're just gonna change the. Okay, anyways, that's super bad. Anyway, camera projection and implemented. For now, yeah, we're just gonna keep it as, I don't know, 0 or 16, just like it was before, and then we're gonna change it depending on the renderer, basically. Because for some reason the camera projection needs a lifetime, which is super weird. Anyways. So right now we gotta actually no, we gotta do it this way. Perspective dot aspect ratio, and then here perspective dot FO. But hold on. Yeah, perspective dot FOV, YFOV, and then the perspective Z-near. And perspective Z far. Let's go. What's up with this? Expected option but found F32. Option? Why option? That's super weird. No idea why would you need an option here, but let's say some. Maybe the in algebra got changed or something. Yeah, I gotta look into the documentation because that seems maybe outdated. Yeah, let's check perspective 3 documentation because the guide seems to be outdated in that point. So let's go to in algebra here, go to documentation. And that should do the trick. API documentation, algebra. Let's look for perspective 3. Now there is another crate called in algebra GLM, but it's just a wrapper to make graphics easier to deal with, but no need. I think perspective 3. And let's see. So new. What? So why it's an option then? This is super weird. I'm confused now. This is perspective 3, and we're getting a new. Oh, it's not an option, so what's up? Oh, okay, because these are options for some reason. Okay, great, fine. Let's say dot in wrap. Yeah, generic. I've put it in a trap, so no, it's not outdated. It seems like. Yeah, there you go. The YFO, though the YFOV shouldn't be in wrapped, isn't it? Or doesn't have to. Yeah, so these doesn't have to be enwrapped, but the aspect ratio have to, and the perspective z-far have to. Okay, good. Now we got the transform. And is the transform also have a lifetime? Yeah, no. Great. Okay. So so is it decomposed or matrix? Okay, let me see the camera transform currently how it is. Is it passed as a matrix or as a okay. So the camera transform, it's a decomposed. Okay, so Blender uses decomposed, seems like, and then we could turn it into a matrix. So translation, rotation, and scale. Okay, lovely. So let's actually create an algebra transform out of this, and let's see how the guide recommends that. Hopefully, let's see. So point new orthographic. Should we just create like orthographic projection perspective 3 this matrix blah blah blah. What about, so what we need to store currently, because in algebra is more fine in details on how you want to do things. So right now we want to store basically the translation and the rotation and what else? The rotation, the translation, and the scale, right? Although in this case we don't really need the scale, but yeah, let's see how we can do this. Direct isometries. I don't think an isometry would do the trick, no? Okay, there you go. This is good. So if you want just translation and rotation, then you could just go with isometry. Composition, because that's a composition of rotations and translations. If you want the scale too, then you gotta go with similarity, I think. Yeah, uniform scaling, of course, as long as it's uniform. If it's non-uniform scaling, then you would go with affine, I guess. And yeah, plus invertible operations, projective, non-invertible matrix transform. Okay, I think for a camera at least you only have really, I think, a rotation and translation, so we're gonna go with the isometry, I believe. Yeah, I think so. Yeah, let's go with an isometry. Let's try with an isometry. And for that, let's go to an algebra documentation, I think, or something. Like, or let's just go with direct isometries here, I guess. Our rotations followed by translations. And here, new, build an isometry that rotates by x, saying that norm radius. Identity from parts. Okay, so I guess from parts you could give it like t and rot. So, and the rotation t, which is a unit complex number, unit quaternion rotation matrix. Nice. T rot. And what's this? It is around the axis x. Build an isometry that rotates by x angle dot norm. I guess norm is normalized, but translate by the vector t. Not sure. Let's go to the documentation here. You can see that it's very kind of fine but anyways, let's see. How do you do it? Isometry. Let's see. What I'm doing here? Hold on. No, go to documentation. Where is it? Yeah, there you go. And let's go to isometry here. Start figuring it out, because I don't really have a lot of experience with algebra. It's pretty interesting though. Algebra isometry. Basically, instead of like your normal library where you just have like a matrix and that's it, which is kind of fine for most cases, but basically this library gives you more constrained types. So, and that's pretty nice because it can help with optimizations first. Second, it can help with like type safety for, I guess, your calculations, to make sure like your calculations are correct, I think. But yeah, anyways, whatever. So basically, for example, an isometry and all of this stuff is just more constrained matrix. You know, it's like, it's just, instead of having whatever matrix, here in isometry you just have rotation or translation, and like both rotation and translation, but without a scale. If you want a scale, then we got to go with a similarity, I think, or what is it called? Anyways, let's see, aka a rigid body motion. Let's see, from a 2D vector and an or angle, from a 3D vector and an or an axis angle, and rotation parts. Probably what I want is this. Create a new isometry from its and rotational parts. So I have a quaternion. I just have to make it an algebraic quaternion, and I do have a translation. So yeah, I think we gotta go with isometry tree from parts. So yeah, how we could do this now? Camera transform. Yeah, what is this? Let's get the decomposed part. So match decomposed. Decomposed. What is it called? Transform matrix. Otherwise, for now, say in implemented. And let's see. Actually, don't import it. Just what is it? What is it called again? GLTF scene. Okay. We'll just go with this because I don't want this to clash with an algebra fully. So yeah. And this would give me the decomposed part, I think. Which is going to give me the translation, the rotation, and the scale. Okay. Though I don't care about the scale in my case, since it's just a camera. The scale is always like 1, 1, 1. So yeah, right now we got the translation. Let's build the translation. Translation 3. Okay. So, oopsies. Okay, great. So let's say isometry. What's happening here? Okay. So let's say isometry 3. Come on, isometry. Isometry 3 from parts. And here I gotta give it a translation and a rotation. And let's see, so expected translation but found that. Can it convert into it easily? Seems like. What about rotation? Seems like 2, which is interesting. And yeah, so we got the camera isometry. So that's pretty cool. Now, of course, to pass this through the API to the GPU, we gotta actually convert all of these into a matrix, pretty much. You cannot, of course, export isometry to GLSL or a projection or whatever. So at the end of the day, we're gonna going to actually convert them into matrices. But this would help basically in the CPU side. Anyway, so I think right now we got the job done. Maybe let's just make sure everything is fine here. Okay, so the trait from F32 is not implemented for unit quaternion F32. Okay, great. So you can notice that it's very type safe. It tells you that it should be a quaternion and a unit quaternion to be exact. So that's pretty cool. That really helps, I think. So quaternion F32. Okay. So I think we gotta basically build a quaternion first out of this, I think. So okay, how do you build a quaternion? An algebra unit quaternion. Interesting. Why GLTF also have a unit quaternion? That's very cool. Okay, if I try to build a unit quaternion here, if I say from rotation dot into, or just rotation basically, would that work by any chance? The trait from U32, yeah, no. Okay, what about a quaternion then? Yeah, and then let's try to get a unit out of it, I guess. Or norm, maybe? No. The norm of this quaternion. No, that's not what I expected. Normalize. We could try to normalize it, but can we say just into here? Let's see. Oh my god, what's up with this? Required for quaternion F32. So the trait from quaternion is not implemented for unit quaternion F32. What? What is units, by the way? Has a unit norm. Yeah, like, okay, what if I normalize this? Would that help? But it doesn't seem like it gives me a unit quaternion. What? Very weird. It should give me unit quaternion, but it's not. Let's see. Okay, what if I said unit new or whatever, something like that instead? Let's see. Quaternion from. Okay, let's try this. Let's try this unit. Right. New or something. Or from quaternion from rotation. So that should probably normalize it then. The trait from quaternion is not implemented for unit. Okay, what about new? Super confused here. Multiple new found. Candidate 1 is defined in an impl for the type unit quaternion T, and candidate 2 is defined for unit complex T. That's interesting. Okay, can I enforce it to be unit quaternion T? By any chance? What? Multiple new found. That's weird. I mean, normally what I would expect is that you would just normalize the quaternion and it would give you back a unit quaternion, but that somehow isn't the case. Okay, what about quaternion then? Let's see. Is there anything here about unit? Quaternion, see the type alias unit quaternion for a quaternion that may be used as a rotation. Oh, see the type alias unit quaternion. Interesting. Okay, where's the new function? Well, anyway, I guess it's unit new normalize from axis angle. No. Interesting stuff. So you say unit new normalize. So that would normalize the vector. It would make it an axis, and then you use the axis and the angle. I guess what I need maybe here is unit quaternion instead. And remove this weird stuff. Is that the case? What? Trait from is not implemented. Okay, what about new normalize or something? Axis angle. Try new? No. Let's say new normalize, and it needs a quaternion. That's weird. Okay, what about from? Okay, it can get it from rotation 3. That's interesting. From axis angle, from Euler angles. Okay, let's make a rotation 3 out of that, right? From rotation 3, I guess, is what I need here. New or from. And let's give it our rotation. But hold on, why the rotation is X, Y, Z, W? What the? Are you kidding me? Hold on. Why the rotation is for stuff? Oh, it's a quaternion. Oh my god, I see. I thought it was Euler angles. Alright, so I need it from components basically. I need to create a unit quaternion from components here. Damn, so that why it wasn't working. It was basically, I see. Can I construct this from components or something like that? From components. How do I do that? Yeah, how do I construct it from components? Let's see, is there any... Oh, I could just give it the components then? I think so. Okay, what about... Well, this is rotation quaternion, okay. So let's try to give it rotation 0 and rotation 1. Yeah, that was the key that I was missing, I think. It was a quaternion, but I thought it was 0, 1, 2, 3. I thought it was that Euler angles, but anyways. So type mismatch, expected vector found. Unit quaternion. Okay, can I convert it now into unit quaternion? Nope. Well, damn it. Like, even when you do normalize, it doesn't give you the right thing. This is stupid. Okay, go back to unit quaternion. How do you construct it from an actual quaternion? Angle to rotation to lerp. Unit quaternion. Oh, new normalize. Oh, okay. Hold on. So you say new unit quaternion. You? Where's my quaternion have gone here? Okay. Well, this is pretty interesting stuff. I guess maybe we gotta say new normalize here. Normalize the given vector and return it wrapped on a unit structure. I think that's probably the case now. Right. Oh my god, I guess we have finally done it. Finally, oh, that was crazy. Yeah. I was expecting that. But anyways. But why this is WIGK? Ooh, why? I don't think that's the case here. Or is it? This is XYZW, where W is the scalar. I gotta watch out for this. Create a new quaternion. The order does not follow the storage order. The storage order is IGKW, while the arguments for this function are in the order WIGK. But why? Why do that? Yeah, that would have easily tripped me. I don't know why they would reverse the order. Rotation 3. So yeah, I think that's maybe it. Or like IGK. Super weird. IGK is actually the same order. It's just that W is in the start. Okay. I have no idea why. So rotation Z, rotation 1, rotation 2, and then the W is here. Okay, great. So this should do the trick, I think. This should do the trick now. So yeah, finally I think we are done with an algebra here. Possibly. There you go. Here we got a camera projection, and you got a camera isometry, which contains the rotation, some values, some chords, some data, blah blah blah, and some translation stuff here. Okay. Now what we gotta do, so we got the camera isometry and we got the camera projection. Now we actually gotta create the camera transform out of it, basically. Perspective 3 and isometry. Okay, let's check out the guide about in algebra. Where's the guide of in algebra? Okay, so we have gone through this. Right now I think we're gonna need the computer graphics recipes here, and let's see. Using raw, build an MVP matrix. Let's go. So here we got a projection. Yes, we have built that. What's next? For now, we're just gonna assume, like, we're not gonna take into account the model matrix for now. Right now, we're just we want the view and the projection. So how to do that? Model, view, projection. Combine everything. Projection. Oh, I guess this is the model of the camera itself. I don't think. Projection. Mat model view as matrix. So yeah, the view right here is isometry, which we already got. And then we got the projection. Now what we do, projection dot inwrap times view times model. We don't have a model just yet, so this would be projection times view dot to homogeneous here. Basically, I think projection is not constrained like the other ones. I think it's not linear, kind of. I don't know like the right term, like technical terms in mathematics, but anyways, so this is how you do it. So projection in wrap. I don't think we need. Do we need in wrap here? What that does? Oh, I guess this in wrap would give me the matrix back, and then here we turn this into homogeneous to turn it into a actual matrix. Okay, gotcha. So let's create the view projection right now. This is very interesting. And what I'm doing, this should be camera isometry like this, and here camera projection, or camera perspective, to be clear. For now about that, let's go with that. Okay, so view projection is equal to projection dot inwrap. Where's projection? Oh yeah, camera perspective. Well, actually they called it projection, right? So yeah, that's okay, fine. Yeah, let's go with that. Fine. And let's call it camera projection dot inwrap. This I believe would give me the matrix back, but it seems to be deprecated. Retrieve the underlying homogeneous matrix. Deprecated, use into inner instead. Okay, so let's use into inner then. Retrieves the underlying homogeneous matrix. Okay, lovely. And then we gotta do multiplication by the isometry. But the isometry should also be turned into homogeneous coordinates, basically a matrix. So let's go with camera asymmetry. To homogeneous, converts this asymmetry into the equivalent homogeneous transformation matrix, the same as self to matrix. Okay. And we finally got our beautiful matrix in a type safe manner. An owned matrix column major matrix with arc rows and C columns. Because this is an alias, now it's method unlisted here. See the matrix type 2. Okay, that's pretty cool. Okay, so I think right now we got the type that we can right now go ahead and make into a uniform buffer and stuff like that. So that's pretty cool. Let's go. Okay, so how we can make a uniform buffer now? Let's see. So we got device and host. Okay, let's create another buffer here. Let's uniform buffer. Device buffer allocator dot allocate slice, and here we're gonna say not allocate slice. For now, at least, it's gonna be allocate sized. But honestly, I want to make first of all a uniform struct. Uniform. Okay. And the uniform for now at least would only contain the camera, the view projection. So and the view projection would be this weird O matrix thing. O matrix TRC. Type parameter R. Rows, columns, and storage, I think. And then T, of course, is the type. So, okay. Uniform. And owned. Okay. O matrix. And here what we need again? I need TRC. Okay. So for the T, we're gonna go with F32, isn't it? I think so. And R, I'm not sure. Let's just go with something until it tells us that we're wrong here. Expected constant provided when a type was expected. Oh, type was expected. So what is that then? RC. Data is S. RC is dim. What is dim? I guess a dimension, but how would you... Weird. Okay, let's go here to the documentation. There you go. And let's go to matrix. Oh, matrix. Actually, let's go to matrix here. And TRCS. So constructors of statically sized vectors or statically sized matrices. For the matrix number of rows, Like it says that it is possible to give a value, but why? Weird. Okay, let's just see. Wrong number of type arguments. But how do you do it then? This is stupid. Let's see. Let's see the guide, I guess. How do you do it? Performance tricks, generic programming. Probably generic programming is what I need here, maybe? No. Points and transformations. Homogeneous coordinates. How do you create a damn matrix? Type. Then start it. Vectors and matrix. There you go. Yeah, what I'm doing exactly that. As a matrix that owns its data as opposed to matrix which borrows their data from another matrix. Oh, okay. You say U2, U3, blah blah. What's that? U2 and dynamic. Okay. So I can get that from NA. Okay. So NA U2. Let's go with U2. Or yeah, honestly, let's say use an algebra as NA. And let's say NA U3, for example. Does that make sense? Huh? Just comment this for a second. There you go. Okay, it works. Lovely. So that's how you actually do it. Oh my god. From two type num, some weird stuff. Anyways, so that's how you do it, I guess, though I'm not sure if this would. Yeah, let's make a uniform first. Let's make the uniform data here. Well, we gotta actually make it in the, but anyway, let's just make it here for now. So uniform view projection. Okay, uniform. And yeah, and I think that actually works, isn't it? Seems like, which is interesting. Did I really get the dimensions right? No idea. Let's see. Let's make sure the dimensions are correct. Okay, expected 3, found 4. Alright, so it's probably 4 dimensions. View projection. Lovely. I think right now we have created our beautiful uniform, which contains, of course, a matrix of cool stuff. Lovely. That's what I'm talking about. Amazing. Amazing. Just amazing. Okay. Right now it's actually allocate sized. And sized, I think we could do this and then maybe uniform like this. And is that correct? And I guess I gotta give it the length maybe? No, I don't. That's how we do it, right? Now we have allocated a device buffer right now for the uniforms. Next up, we gotta create a staging buffer for it too. So basically I'm just gonna copy something like this, and let's say uniform here, and here host buffer, of course, but instead of slice, in this case we only have one object, so allocate sized uniform, I believe, or maybe it could even just figure it out itself, infer it, because we're gonna actually no, we can't, right? Makes sense, because this is not the way it's done. Anyways, let's go with uniform. And yeah, right now we created the staging buffer and the device buffer. Amazing. So now let's actually write data to it. So basically something like this. Let's call this uniform in the writer, and uniform here. Copy from slice, and well, not copy from slice, just copy, I guess copy from, isn't it? Copy within. Oh, I see. So this should be uniform buffer here. And I believe, yeah, I believe since it's just one element, I could probably just say uniform writer, and I believe like this equal to uniform. Isn't that correct? Yeah, I think so. That's pretty cool. Amazing. Okay, so I think right now we have created some buffers and basically allocated. Let me make sure that this actually at least compiles and stuff. Right. The trait pod is not implemented for Vulkan device new uniform. Oh my god, great. Okay, let's see how we could fix that. Okay, let's first of all derive pod here and stuff like that. Well, basically derive buffer contents. And let's see. Is that all we need? Deriving is only support for types that yeah, I forgot. Wrapper C. What else? For this interesting. So I guess that would work now. Yes, it works. Lovely. But we have some error, interestingly. The device memory is not. Oh, okay, I see. So I'm doing something wrong here. Hold on. A uniform writer, uniform. Oh, uniform staging buffer. Okay. Vulkano doing this job. Okay, great. So this should do the trick now. Right now we just have to pass in, I believe, the uniforms, and possibly we'll see how it goes. So alrighty, so right now we have no error. Lovely. So right now we're actually having a buffer for the uniforms. Now how we could actually pass it, let me see the reference, the Vulkano reference here. Let's see, uniform. So uniform buffer is a buffer. What's up with that? Okay, it's doing that stuff that we have done. There you go, nice. And what else? Okay, so we gotta add a descriptor set. Oh my god, I see. I forgot about that completely. So we gotta make a descriptor set, allocator 2, and here write descriptor set buffer 0. Okay, great. What else we're gonna need? So the set, then I believe we need the binding. How would you do that in here? Yeah, let's go with the, let's look for the binding, or where the set is being used. Let's see, descriptor set allocator, there you go. It's creating an allocator there. else? Descriptors set, we have already seen this, right? And bind descriptor sets. You bind the descriptor set to graphics using the pipeline layout and the set, and there you go. Okay, lovely. But what about the pipeline layout? Is there anything that changes there? I believe there is, but pipeline layout create info device clone. Not really what I... Oh, okay. From stages. Yeah, okay, let's try this out. Let's first of all make an allocator for the descriptor sets. So where I'm gonna do this, let's go, I believe maybe let's go here. Where is it? Yeah, let's go with this here. Why not? And let's say descriptor set allocator is equal to standard descriptor set allocator, and let's create new, and here we gotta give it an arc device. And what's next? We're gonna need a standard descriptor set allocator create info. Great. And what else? We could probably just pass a default here. Okay, and now let's wrap this into an arc just to make sure. And there you go. So with that, we should have a descriptor set allocator. Now we gotta actually create the descriptor set itself. So how to do that again? Set equal. There you go. So you just say this after the layout, which makes total sense. Okay, let's create a descriptor set here. Took me a very long time to understand what descriptor sets are for. But I'd like to think about it just like, you know, like you have descriptor sets and descriptor bindings. And yeah, I'm gonna explain more later on. Anyways, for now, let's just try to make this work, I think. And the descriptor set, let's import it from here. And what about these guys? Import. And here, uniform buffer, sub buffer. Great. Here we gotta give it the uniform buffer. So uniform buffer, okay. And what else now? In wrap. I'm just gonna do this. If you notice, we're just assuming that the mesh is static, we're assuming the camera is static, whatever, because we don't need dynamic just yet, but we'll see, we'll do that when we need it. Anyways, so we got the descriptor set now. I think right now we gotta bind it. So how would you do that? Let's see. Keyword set is being used again. Let's see. Bind descriptor sets in when we bind the vertex buffers and stuff. And yeah, that's pretty much it. So right now we're just gonna give this to our, we're gonna expose this to our renderers. And hopefully if everything went right, we can have our thing. So set descriptor set new. And do we need the right descriptor set? Yeah, I think, yeah. Represents a single write operation to the binding of a descriptor. Yep, correct. So let's go to, and let's add a descriptor set here. So, and what is the type of descriptor set? I think like this, probably. Probably not. Let's see. Descriptor set. Huh, hold on, let's check set again. Oh, what? Resource in command. I guess it's just gonna be resource in command, maybe. How would you actually? Yeah, what is this? Hold on. Come on. A node? What? Let's remove this for a second. Not sure which type I should use here. Not sure what Vulkano uses there. Let's see. Consider importing this trait. Sure. What? Let's go ahead and import this trait. Let's try now. Must be defined only once in type namespace of this module. Okay. Oh my god, we have. Ah, I see. We have a clash here. Okay. Maybe we don't need this one or something like that. Or otherwise, you could even just make, since this is just a trait, I think we could just name it something else. I don't know. Descriptor set trait. Could alias it, I believe. And let's see if that was the problem. And descriptor set variant, not a module. Yeah, no, the one we imported I think is wrong. Yeah, probably. So let's keep this as it was. I'll just remove this thing. And let's see. Damn it. Let's go with descriptor set as trait. Okay, as descriptor set trait. Honestly, all traits should be called, like, should be maybe prefixed with trait or like suffixed with trait, because a lot of times I get this trait clashes. And it's telling me to import that now. Nice. Import and white. Oh. Okay, if I add this now. What? No function or associate name new found for trait. This doesn't make any stupid sense, does it? Okay, let me see the example what it actually imports, because this is crazy. And let's see, descriptor set. Where is the descriptor set here? It's right here in standard. Okay, in allocator, standard descriptor set. Yeah, descriptor set. Okay, Vulkano descriptor set. Great. So let's go ahead and do that. Let's fix that. On descriptor set. Let's remove this weird thing. Let's say use Vulkano. Descriptor set, descriptor. It's a trait. What? I'm very confused right now. Oh, it's in allocator. No, it's not. So why it doesn't work then? I'm super confused now. You know what? Let me do something here. Let's go to Vulkano. Yeah, let's go to Vulkano project here. And let's go to the example here. So what is it called? It's called teapot, I think. Vulkano teapot. Where's the examples? There you go. There you go. And let's see what this descriptor set is all about. Okay, what is this stupid type? It's Vulkano descriptor set. What? And why it's telling me it's a trade then? This is super weird. I guess I'm having some weird clash. Okay, let's see. Let's remove all that stupid descriptor set stuff, okay? Let's remove all that. Because I'm probably having some clash here. Yeah, let's remove that stuff. Descriptor set. All of that, poof, and let's see, what else do we have here in descriptors? Okay, great. So now let's try again. Let's start with that descriptor set stupid stuff. Descriptors, there you go. Okay, let's try first this. So we have these two. It doesn't make any sense. Okay, let's try to import. I don't know why my IDE doesn't give me that option. Yeah, this is a struct, so yeah, let's try this out. Vulkano descriptor set. Okay, let's try this. Use descriptor set. Can't believe this. Vulkano descriptor sets. Oh my god, no way. What? Why it's actually a trait here, and in Vulkano it's a struct? I'm losing my mind right now. I'm literally losing my mind right now. Here it's a struct, and in my project it's a damn trait. How? No idea. Oh my god, I think I got it. We're actually in master. Maybe it got changed, so okay. Let's go to the right version. Damn it. Let's go to the right version, because yeah, master. Let's make sure we are in the right version here. Tags 0.34. I always forget to change my version, and yeah, examples. Okay, let's go to the teapot right now and see how the descriptor sets work. It's called persistent descriptor set now. That is crazy. Yeah, basically I was following up with the wrong version. That's why you should make sure. Damn it. Anyways, let's go ahead and fix this. Damn it. Let's go. Righty. Damn. Well, I have fallen into this trap, so we don't have to. Let's go. Persistent descriptor set. Yeah, actually, I know about that, but I always forget to change it. So, are you going to go back to your Roblox plugin? It's a bit broken when I use your own. No, I have left Roblox at this point. Create reference. Persistent descriptor sets. Richie. Now, where's this stupid thing now? Okay, please let's change this descriptor set. Why it's not showing me this now? Oh, maybe it got changed the way. No idea what's up with this. Anyways, let's go with set here. Oh yeah, I see. Let's go back a second. Oh, I cannot. Oh, we are in Vulkano teapot. Damn it, I see. Alright, let's go to the descriptor set now. Persistent descriptor set new, and let's go. Now we're gonna need an allocator convert to this. I don't think it's using an arc anymore, and the layout. Expected arc descriptor set layout. Okay, so there's a new one. Okay, so descriptors set layout. Okay, how they're creating the descriptor set layout? Let's go. Oh, actually, I think they're getting it though. Yeah, they're getting it from the pipeline. Layout. Oh yeah, pipeline layout dot set layouts dot get 0 dot inwrap dot set 0. Yeah, you don't do it this way. You say layout dot. Yeah, it's super confusing. In master, it was super nice. But anyways, get 0 and inwrap. Damn, okay. Found. Okay, so we gotta clone this now. Oh, we could just pass this in directly. And we don't need to unwrap here. We could just say this. And there you go. Oh, right. Now we got the set. What's next? Okay, just say unwrap. But really, the latest version of Vulkano really handles this much nicer. Anyways. Okay, what's up with this now? Pool sizes is empty. Interesting. Pool sizes is empty on, I guess, the descriptor set allocator. So yeah, let's see how we're making the descriptor set allocator again. Let's see. So new, and here we're saying default. Let's see how it's doing it here, because I was following with master, which is very different. But why pool sizes is 0? Yeah, why pool size is 0? Okay, what about set? What we do with it? I mean, we should be able to just bind the descriptor sets now. Weird. Anyways, let's just try that out and see what happens. So, where we're creating the set now? We're not creating. There you go. Okay. So it's an arc persistent descriptor set. Okay, that makes sense. Persistent descriptor set. And wrong number of arguments expected at least 1. There you go. Okay, it's fine. And now what? Let's right now expose the set to the renderers. Add missing field. Oh, we need to wrap it in an arc first. So set equal to. Oh, it's already an arc. So what's up with that? Expected an arc descriptor set but found arc. Huh? Oh, right now it's fine. Weird. Anyways, so that's basically it for that one. Now let's actually make a getter here real quick. Pubfn Control Alt Shift O. Control Alt Shift O. And yeah, let's see what GitHub Copilot would do now. Come on, bro. And yeah, make the getter for me. Okay, let's go. Now what? Let's go here and say okay. So now what? Yeah, let's go to where we're binding stuff now. And let's bind the set here. Bind descriptor sets, pipeline bind points, graphics, and pipeline layout. Where do I get the pipeline layout again? I guess maybe self.vulkan device to pipeline layout. Self.graphics, or yeah, graphics pipeline, then you can get the graphics pipeline, the pipeline format, right? No, the layout, sorry. Let's get the graphics pipeline first, then the layout. Okay. This function takes 4 parameters, okay. So the first set, 0. And now here we got the descriptor sets. Okay. How do you do this? Bind. Yeah, you just give it the set pretty much. So self.vulkan device.set. Okay. What's up with this? Yeah, we gotta clone this. Our clone. And there you go. Oh my god. Now let's see if this thing works by any chance. I cannot find values set in this scope. In self. I think we're making it in the wrong scope, right? So where we're putting this set though? Yeah, who's getting this set? No one. Okay, no one is consuming this set here. So, but what it needs the layout. It needs access to the layout. Oh, okay, fine. Let's actually do this now. And basically, Yeah, here let's say graphics pipeline layout. And that should hopefully do the trick. Required by bound and disassociated. Okay, go back right now to the Vulkan render, bind descriptor sets. And here, now basically, several Vulkan, oh, here, okay. So let's clone this. I don't know why the Rust analyzer is losing its mind now. But okay, our clone. Okay, we have a problem. That's super weird. Let's go to let's add the uniforms to our shader now. So where's our shader? Yeah, I think it's getting the reflection from that, so that possibly could be the Y. Let's get our uniform now. So layout uniform push constant data. Okay, so layout location 0. Actually, it should be binding 0 and set 0 and stuff like that. Where's the? I'll say version. Oh yeah, it's in a separate place. Okay. So vert.glsl, let's go, and here how you do it. Set 0 binding 0, yeah, as expected, and then we can get that projection matrix. Great. Well, let me just copy this so I don't miss anything. And let's go here. Let's make this like that. Currently, we're only passing one single thing, which is the view projection matrix. And yeah, it's matrix 4. And yeah, uniform was we call it data. I'll just call it uniform, I think. I don't know. Anyway, let's go. What's up with this now? Expected uniform, expected semicolon or identifier. Really? In GLSL, expected uniform, expecting an expected uniform. That's weird. Oh, I see. That's why they're calling it uniforms. Because it's a keyword, I think. Yeah, pretty much. Oh, come on. Yeah, the pool sizes stuff again. Yeah. Okay, where that happens, in the persistent descriptor set. And the descriptor set in here. It's getting the scripture counts here. why pool size 0? Create info to pool sizes. Yeah, pool sizes, here you go. It's getting it from the layout. Maybe the uniform is getting optimized out because we're not using it. So let's make sure that's the case. Let's actually use it. Vulkan device. Position. Okay, so right here we gotta say view projection times vec4 position, and let's see. But I don't think that's the problem, honestly. Uniforms, view projection. And let's see. Yep, console. Oh yeah, uniform buffer. Yeah, I forgot. Okay, hold on. So let's go to the allocator. I think we're getting it right now. We're close. So what is it? Uniform? Okay, not here, of course. We want it in device. Uniform buffer. Okay. So let's see what we got here. Let's add here buffer usage. We're also using it for the uniforms now. Uniform buffer. And let's go. Great. And we got nothing. Some calculations are probably wrong here. Let's see. But at least it's working now. So it's working. It's probably just the calculation is wrong or some logic error or whichever. So let's see what's happening. Time for some render doc again. Okay, let's see. Launch application, launch it. No. Import screen. We probably just need a minus somewhere in the calculations. Anyways, let's see. Key submit, key present, blah blah blah, whatever. Color pass. Anyways, let's go to pipeline, mesh view. Okay, so this is our vertex input, and our output isn't even in the viewport. Oh, I see. Okay, it doesn't contain anything. It's like zeroed. Okay, why the vertex output is zeroed? Interesting. So zeroed. Why? Can I see the uniforms that are being passed? There's uniforms here. Oh yeah, the uniforms being passed is like just zeros. That's interesting. Why? Okay, let's see why we're passing zeros in the uniform. Great. View projection. I mean, we have seen that the view projection is fine. It was not zeros. Is it the way we're writing to the uniforms? Oh, we're not copying the buffer. Yeah, let's copy the buffer. Makes sense. All right. Render doc saved the day again. So uniform buffer. And here uniform buffer. Let's go. And let's see now. Well, this is interesting. And we're still getting nothing. Well, now why? Let's run render doc again. Launch, capture, and let's go. Let's check out the pipeline, mesh view. Let's go to draw indexed. This is the vertex input, this is the vertex output. Yeah, we're indeed getting. Oh, maybe our camera is actually in the center? I think so. Yeah, those are big values. Yeah, I see. Those are big values, very away from like. Oh, there you go. Okay, that's interesting. That's interesting, and I also think that's probably gotta be reversed. Anyways, we should basically zoom out our camera a bit, I think. But no, I mean, we're not passing the camera or what? Hold on. Yeah. Hold on. What? I'm confused now. Frag color. Hold on, let me see how we're doing that. View projection matrix. Camera isometry homogeneous. And the camera isometry is what contains the translation of the camera and also the rotation. Maybe we just need some minus somewhere. Alright. Translation. Run the C++ debugger and check if it has the same values over render doc. It's probably not the problem there. I think you're just missing some calculations here. Not really missing, but probably need some minus here or something like that. Basically. Basically what's going on here is that geometry is there, but the camera is looking this way, I think. Which is interesting. I mean, what should happen is that we should get this, but for some reason it's not really working out. Or it's working out, but the coordinate system is different. Oh, well, that could be the case. So I think what I'm gonna do maybe, for now, instead of getting the rotation from the thing, we could make the camera look at, yeah, we could make the camera look at 0, 0 for now. And then try to figure out how to reconcile between Blender's coordinate system and, because I'm not sure. Yeah, anyways, let's see. So instead of getting the rotations from here, I'd like to make it look at, how can I do that? Isometry. Here where we're getting the rotation, so we need to give it a quaternion. Okay, let's try, I guess. Blender is Z up, while in Vulkan Z is depth. Oh. Vulkan Z up, and in Vulkan Z is a depth. So let's see. Z is up. Translation here. Okay, let's say here translation 3. Swap Z and Y maybe. Which Z? We'll see. Hold on. Translation new, and we could get translation. Swap the Z and the Y. Okay, let's try. In the translation, you mean? The Z and the Y. Translation 2. Yeah. Translation 1. Let's see if that would help. What about the rotations? No, still not getting anything, but let's see how render doc right now does. I should honestly, well, fine. Anyway, let's just go with Emperor screen and let's go here and let's see, draw indexed, and let's go here to pipeline mesh view. Yeah, same problem. Still right there. Yeah, okay, let's make it the camera look at the center. Let's see. So I'm not sure how we can do this here, but let's just say this. And for now, let's just keep this as it was before, just so we don't have any surprises for now. And here let's try to say, maybe you can Google how to do that proper. Probably a common task. GLTF to Vulkan coordinate system. Between OpenGL and Vulkan. Oh, I think GLTF uses like the coordinate system of OpenGL. I think. I'm not sure if Blender is also contributing to this craziness. Probably not. At least shouldn't be, but no, Blender GLTF doesn't specify any course. Okay, so yeah, it's basically between GLTF and. So probably what we need, like, hold on. What is GLTF coordinate system? Is it? I think it's probably OpenGL, but oh, GLTF doesn't care about the coordinates. Well, it does need to care about the coordinates because we have the camera translation and stuff. And yes, it uses a right-handed coordinate system. I think Vulkan uses a left-handed system. Not the world thing. What do you mean? The spec enter the coordinate system, the cross. As is used by, okay. As used by OpenGL, alright. So OpenGL coordinate system to Vulkan. That's what we need, I think. Okay. Perspective matrix. Oh. Handling differences between coordinate systems. Let's see if this would help by any chance. This is the expected results are set up like these. I scaled the projection matrix. Yeah, I remember someone actually had done this before, but GLM force left hand. Well, it's also about yeah, in algebra, does it use left-handed or right-handed coordinate system? Perspective RH. Yeah, the math library. Yeah, let's see an algebra coordinate system actually. This is not what I wanted. Let's go docs, user guide. Also, what do you read? What do you read from the GLTF? Yeah, I read, like, for now at least, I read the camera transform, like camera translation, camera rotation, and yeah, that's basically what I get from the GLTF currently. Yeah, I get the translation and the rotation, which it was here. GLM converge. I guess it's not talking about. Yeah, no. Okay, computer graphics recipes then. I guess for now let's just hard code it instead of getting it from the. Yeah, let's try that first. So currently maybe the matrix is stored in row major and Vulkan use. Everything is possible. So instead of getting it from GLTF for now, let me hard code this and make sure that at least the mesh is correct. I mean, the mesh should be correct, but yeah, let's just go step by step, I think. So we're getting this. Yeah, fine, import this from an algebra and import this. Okay, and instead of taking the camera asymmetry from GLTF for now, I'm not gonna care about GLTF, and let's just hard code this here like this. So the view is this. So okay, let's see. I think what usually happens is the engine is to own the camera stuff. That your engine to own. What do you mean? It's located. But yeah, this should give us a lot of. Let's see. Point 3 point target view. Vector 3y. And by the way, the model is like X, Y, and the Z. Okay, anyway, we'll see. I'll just try stuff up. You want to own the camera? What do you mean? Camera isometry. Okay, so camera, or let's just call it view, fine. View to homogeneous camera view. Target. Target for now would just be 0, and the eye. Hold on. Let's start here. Maybe something like 100. And let's see. So let's see. This should at least show us something, but weird. Let's see. Well, I have completely forgot about the coordinate system. That could be different. Well, draw indexed. Okay, pipeline, the mesh view. Alright, so we're actually looking at the cube. But what is happening? Do we have calling on? And it's actually very far. And do we have calling on? Because maybe we do. Where's calling? It's in the device, right? Where's call? Should be none for now at least. Okay. So this should, but why I'm not seeing anything at all? Maybe it's too far. Weird. Oh, okay, we're getting something. Yeah, maybe like see. Yeah, we're getting something. Hold on. Go back to the camera. Okay. What about 10 maybe? Oopsies, hold on. I forgot something here. It should be 10 here. Okay. Come on. We should add the depth attachment too to fix some issues, but right now let's just see 0.3 new. Okay. Alright, but the projection looks super weird. Yeah, the projection looks super weird. I'm not sure why that's the case. X and Y should be 0. Hold on a second. Hold on. Okay, back. Let's see. Because you just want to go back a few steps and not go up or left. Oh, I think maybe the projection is weird because we're not taking into account the width and the height. Hold on. Where is the projection stuff? There you go. Okay, we're getting it from Blender, so no. From GLTF, so. Let's actually set it to the swap chain stuff. So, do we have a swap chain here? Or like, we don't have a swap chain here, but let's just hard code this. Let's just say for now 600 this is our initial size. Later on we should actually change the camera projection depending like when the resizing happens and stuff like that, but right now just wanting this to work out. And I don't know, I guess, yeah, maybe that works. It does still look weird though. Okay, let me try to hard code this too. 70 is what I would usually expect. Yeah, 70 like that, okay. I mean, this is what Blender shows for this specific scene. Let's see. Ayo, why am I not seeing anything right now? Oh, it's actually in radians. Okay, it's actually in radians. So for that, we're gonna go with. How do you convert this to? Divided by 360, I guess. Times pi divided by 2. Or probably could just find something in math here. Where is math? Yeah, it's in F32. Okay. Degrees to radians, great. And let's go with 70 here. Come on. Now it's super far. That's interesting. Let's go now with 1 or that looks just right. The camera is far. Yeah, let's see. Okay. What is this? Let's make it a bit farther. 2, 2, 2. Yeah, we are inside. That's interesting. We gotta fix the depth though. We gotta fix the depth by adding a depth attachment. There you go. Yeah, I guess that looks just fine now. Yeah, I think so. That's nice. Though it probably would be better maybe if we go with -2. Yeah, that looks correct now. We just need to fix right now the depth by adding a depth attachment, I think. So try making XY 0. Alright, that was what I was expecting. But look at that, the triangles is all over the world because the depth, we didn't add the depth yet. So right now let's just add the depth. Let's add the depth right now. Nice thumbnail. Someone would make this into an NFT right now. Let's see. Let's find some Vulkano example for the depth now. I never used an algebra before. This is my first time, so I have seen the whole experience. Okay, let's see. Vulkano examples. Alrighty. But since we're using an algebra, it should also be straightforward to, let's say, add Rapier Physics Engine because it's using the same library for math. It's using an algebra, so that's pretty cool. But yeah, average experience with math. Yeah, I have no experience in math. Anyways, let's go with teapot. No. Let's see some other example now to help us with the depth real quick for Vulkano. I mean, teapot should probably help us too. Yeah, there's no depth here. So yeah, let's go to teapot too. And main, and let's look for what we need to do here. Depth. Currently a lot of things are hard-coded, but yeah, step by step for now. Okay, so well, we're using dynamic rendering. I had never done depth with dynamic rendering. That's going to be interesting. So we add a new attachment to the render pass, and that attachment would be D16 norm. Okay, and then the depth stencil. They're using the depth stencil too, or? Anyways, and here they're creating an image view. I call it depth buffer. Interesting. This is an image view, so. Well, they're also creating an image too. Since it's an arc, it's gonna live as long as the image view. So, depth stencil attachment. Okay, what else? Yeah, I think that's pretty much it. So we're just gonna add this image, the depth attach. Oh, there's also the pipeline stuff. Dynamic render is the thing that skips the render pass stuff, right? Yep, exactly. We don't have any render pass, no frame buffers, none of that stupid stuff. Okay. So we already have the depth stuff, the viewport ready. So for the graphics pipeline, we only gotta add, I think, the depth stencil state. Right. Yeah, let's add this to the graphics pipeline now. Where is it? There you go. Dynamic states. Sounds like pain IDK. I think render pass makes a lot of sense. No, it's actually the opposite. At least for me personally, but I guess it's kind of like a preference. But anyways, depth stencil state. Well, you also gotta remember that Vulkano does the synchronization for me, so that's something to consider, I guess. Import. But honestly, even in raw Vulkan, I really preferred doing the synchronization myself instead of juggling render passes and frame buffers. Anyways, depth state, and what else now? Come on. There you go. Right now we added depth stencil state, which should add this depth, which just gives it compare OP less, which is correct. Right, enable true. Nice. Nice. And what else? The default. What is the defaults? Depth default, depth bounds default, stencil default. Okay, depth default is none. You sure about that? Anyway, depth bounds none. I would guess that's how you do the default stuff. I don't know. I mean, they're using it here, so it should be the case. So, okay, fine. Let's just leave this right now, and let's go to the next step. The next step is creating the depth attachment stuff. No, the image view and the image itself. And for this, we just gotta copy this. And for that, we're gonna go with... Well, where are we gonna create this? Yeah, we're gonna create it in the render. So let's go ahead and the swap chain image view. Yeah, next to the intermediary image, which we use for the MSAA. I'm gonna call this depth image view or depth view. And here we're gonna need the memory allocator, which we can get from the Vulkan device. Come on. Device or allocator. Oh yeah, Vulkan device, .memory allocator, clone. And let's import this stuff here. For the format, it's probably better to go with 24 bits, but fine. Let's just go with this for now. Import. Okay. And here we're gonna need the extent and the format, import Vulkano format. And here the extent is gonna be swap chain.image extent basically. There's this book after I read it, it helped a lot with how I manage render paths, like the approach you reason. Like you write a frame graph, describe the input to a step and the output, then generate from the file automatically and never touch the codes. Yeah, I see what you're talking about. It's kind of like a render graph basically. Can I see the interview? And type mismatch. Okay. So now make sure you do this and you do this. And the allocation info default, fine. By default you would put it in the device. And depth stencil attachment, transient attachment, nice. Great. And I don't think you need to give it the image type because the default is dim2d anyways. So we don't really need this. And yeah, that's, I believe, pretty much it to create a depth view. Now in our, let's see, oh, by the way, when I said intermediate image, we're actually allocating an image. I have just didn't notice that. Yeah, there you go. Anyways, so now where are we gonna use this again? Depth buffer. Yeah, right now we need to pass the attachments, right? Do you work as a graphics dev, by the way? No, in fact, I'm just still new to the graphics development and low-level development in general. So yeah, I'm still a beginner pretty much. I'm just showing my experience right here. So yeah, view and depth buffer. Yeah, that's what we're gonna do now. Okay. So let's go right now to where we're beginning the rendering. And yeah, this is going to be interesting because we're not using render passes. Let's see how we could do this. Is there some depth stuff here by any chance? I don't think, but let's just make sure. Yeah, no. Okay. What about here we're using resolve info. Oh, here the color attachments. Okay. And there you go, depth attachment. Nice. So we gotta add that, and yeah, maybe that's pretty much it. So resolve info. Nice, me too. I'm in my final year. I want to get a job as graphics dev after graduation. Nice. Good luck. Image view. I'm doing graphics just because I enjoy it really, and it's low-level development currently. Though I do have a job in game dev, but anyway, the dogs thing. Yeah, it's because of the IDE, right? And thanks to Rust also and Vulkano writing the documentation in the first place. So anyway, so image layout, the stencil attachment. What is this guy doing here? Ooh. Oh, okay. Why it's actually looking for depth stencil? I mean, you're not doing it this way anyways. Anyways, whatever. Let's just give it depth attachment here. Not here actually. Oh, here. Some. And it needs a rendering attachment info. Okay. Oh yeah, I see now why they need that. Right. Makes sense. Okay. Missing fields, initializer, image view. Okay, let's give it this. But instead of intermediary image, we're gonna go with yeah, instead of intermediary image, we're gonna go with depth image, depth view. But I gotta actually add it first. So let's add it. Intermediary image. Okay, let's add it to the struct. Intermediary depth view. The project is so jumbled up, so I'm probably gonna need a separate dedicated slice stream to just clean it up. Anyways, everything is going everywhere. Anyways, depth view. Okay, let's see, add missing fields. And yeah, this should do the trick. We gotta recreate the image again when we recreate the swap chain, but right now it's fine. Self.depthView. Yeah, I think I need the Lloyd OP and stuff, isn't it? Let's see what it's doing here. Don't care, yeah. Clear value none. Okay, so what they're doing here, let's see, don't care. Don't care. Okay, so they're basically doing Lloyd OP clear and store OP don't care. So we only need to change the Lloyd OP here, and yeah. And I believe the format too. No, it's gonna take the format itself. So yeah, we gotta change the Lloyd OP to clear. And what about the clear value, by the way? Yeah, what's clean the depth buffer with? Yeah, it's giving it one F32. One F32. Dot into. Okay, let's say store OP. Well, here? No. Damn, I was gonna do a big mistake right there. Anyways, let's say here store Lloyd, actually, Lloyd OP. Attachment Lloyd OP. Clear. Yes. And then the clear value. Some. And here we basically say 1F32.into. Maybe we'll splat the number into a color or something. I think so. Anyways, so not really the clear value. Not really sure. Anyways, let's go right now into running, I think. And we're missing something. Yeah. This guy. Oh, that's nice. Cause like 1U32 is, yeah. So let's see. Here we go. And let's see. And we have some runtime error. Interesting. The pipeline is being created with fragment output state and subpass does not have a depth stencil attachment. but depth stencil state is some. I see. So we're missing something in the graphics pipeline. Makes sense. So let's see. Vulkan device, graphics, pipelines. Okay. So where we need that, we need it probably in the fragments, something like that. Maybe rasterization state. Or the color blend or the subpass. Interesting stuff. Okay, so we got some depth stuff here, but let's see how Vulkano does it really. Let's see where it's doing the pipeline and what is new there. From render pass 0 in wrap. And let's see, depth range, the viewport stage. The rasterization state is the default. Oh, okay. Depth, but no, we have done this. Yeah, we have done this. So what we're missing here then? That's interesting. With attachment state. Like, hold on, let me watch, not watch, but let's check a normal Vulkan, a raw Vulkan tutorial, how they do the depth real quick. Because I'm missing some step here. Depth buffering, I guess. Is this the one that I need here? I think so, but let's see. SRG. Let's see. Yeah, basically that image. Let's go. Extremely common. Yeah, I'll come back to this later on. Find supported format. Here it's creating an image and an image view. Explicitly transitioning the depth image. Aspect. Don't care about all of this, I think. Oh. Okay. Barrier. No. Render pass. Subpass contains this p-depth stencil attachment. Interesting. Depth attachment reference. And I don't really need this. Anyways. Depth stencil clear value counts. Depth and stencil state. Have we done this? I think we did, yeah. Probably. Yes, we done this, I think. Depth stencil. Stencil test. Okay, I think we're probably p-depth stencil state. Yeah, I think I'm probably missing out on something in the subpass, possibly. Yeah, here we're seeing subpass to into. Where's subpass? I see. Depth attachment format. It's I don't remember what Vulkano have picked. Let's see. Vulkano. Let's see, the D32, I remember something like that. D16U norm, okay? So let's say D format, D16U norm, let's go. And what's up with this guy? We'll just remove this comma here. and this should be sum. Yep, and let's see now. Great. We got an error again. Oh my god. What is this error? Oh. Well, that's interesting. Like, is the depth attachment should be the same samples as? Interesting. I'm using multi-sampling here, so that's crazy. Okay, let's see. Let's try to change the depth attachment to match the, and hope there is no extra steps than that, because I have no clue. Let's see. So, also what this does again. Okay. So let's go to where we're creating the depth buffer, depth view. Where I'm creating, I guess here. Depth view, right. Let's add the samples here. And let's check this out. Hopefully we don't need any extra steps than this. There you go. Let's go, finally. Oh my god, that was crazy. But I think everything would break down when you actually resize. Let's see what happens when you resize, but you don't want to resize the depth attachment. This is what you get. Interesting. Okay, great. Let's see. Let's actually recreate the depth attachment every time we resize. I also gotta care about to actually change the viewport, like the projection matrix, because like that depends on the size, right? But anyways, let's see. Dynamic state depth view. Okay, where's the depth view here? Not here. Recreate the whole pipeline. No, I don't do that. Or the swap chain. No, I'm already creating the swap chain, but yeah, I'm already recreating everything. It's just that the depth attachment that I've just added, it's not getting recreated yet. So otherwise the actual, it would have been crashed if I wasn't recreating the swap chain itself. So yeah, the depth view here, where we're creating this stuff. Let's see. There you go. Why the image didn't resize? Because the depth attachment didn't get resized, so it just seems does that basically. So can't I just do this? Like so. Okay. And here let's actually change this. So self.depthView is equal to, oopsies. Okay, where am I creating the depth view again? I really need to put these into its own function, but yeah, that's for later. Gotta do some cleaning up. But anyways, depth attachment, no, depth view. There you go. Okay, correct. Give me this, and let's go to. And I wouldn't be surprised if we have some problems with reference counting or something like that. Anyways, self.Vulkan device and self.swapchain image extend. And let's see, whatever floats your boat. And let's go. Alrighty. Nice, nice, nice. Alrighty, let's go now. There you go. Well, look at that. The cube is stretched because we have to actually update the projection matrix every frame. Man, Rust is so annoying. The refs thing, and then you get slapped by a lifetime thing. You get all those slaps, so you avoid the slaps later on. Basically, you get all your slaps at the start, so you don't get slapped later. So yeah, let's well, that's gonna be another story. We need to update this stuff. That's interesting, but I really wanted to get like the translation from the Blender itself. Let's try to figure this out now. Actually, let's try to figure that out. Hold on. Let's see if we can figure that out. Let's see. So, where is the other guy? Because if I figure that out, what we could do right then, we could always just like edit our scene, add the camera, add the light wherever we want, and then we could just export it and see it in our renderer, basically. So yeah, we wouldn't even need a GUI at that point, because we have a better editor. We have like a full-blown Blender. Who needs an editor when you have Blender? So let's see. Where's the camera stuff now? Camera projection. Okay. FOV. So. Camera node, okay. So currently, nice. So like the engine takes on big scene from the Blender, right? Exactly. So we don't need the editor. We have Blender. Camera view. Look at RH. The I is in 2 minus 2 2. 2 minus 2 2. Okay. So 2 minus 2 2. Okay. Let's see. So here we got the camera node stuff, I guess. And what else? Cameras, perspective or what? So that's what we get in perspective, but that's not really what I want. Let's go to the nodes actually. Where's the node? Scenes, maybe? Nodes? What? Invalid value? What are you talking about? Well, that's weird. Document nodes. Okay, there you go. And here the camera and the matrix. You can put cam in like x1, 2, 3 in Blender, and then yeah, I'm investigating what's happening here, what's wrong. So translation scale. So the translation here it's 746. 746 is in here. Is the camera is in the right FOV and stuff. Super noob at Blender though. Frame rate now. How do you even set that? I guess in the camera. Perspective, right? Oh, why is having interesting. Viewport display. I think it's the focal length, but I don't want to deal with focal lengths here. How do you make it FOV instead? Huh. Yeah, how would you work with actual logical units instead of physical camera units? No idea. Okay, hold on. Blender camera logical units instead. Let's check out the settings maybe. The settings. Where is settings? Preferences, right? And let's see. Why can't they just put a damn search bar here or something like that? Anyways, viewport, quality display. Not really where I can actually change the units. Editing, duplicate data, 3D cursors, blah blah blah. Yeah, no idea. How to change Blender camera units. Bruh. In the model? Yeah, it does. Or actually, this is what I'm seeing. Yeah, this is what it's exporting. And I guess that's correct. Where's the damn location of the camera? Oh, there you go. Translation. 7 minus 6, 4. But here, 746. So yeah, it's exporting it to GLTF coordinates. So yeah, minus. Like, hold on a second. Is this what I really expect? But I think it would probably. I think I'm gonna leave this until we get some textures on, so I could put like a different texture in. Unless maybe if we can see like some other way, like maybe vertex colors or something, and then I would have a reference point basically. Z and Y are flipped. Let me see. So is this what we were expecting here? What I'm seeing here is the position. Like this is the X axis. This is the Z. What I'm saying? Yeah, X, Z, or is it the other way around? Hold on, what? No, it starts from here. Actually, it starts from here, right? It's black. Try when you read the GLTF, put in the camera like, hold on. So you got the black here, and then you got the X here, you got the Y here, no, the Z here, and the Y goes to down, right? Yeah, the Y goes down, and this is the X, and this is the Y. In Blender, what is it? Z is actually up. Z is up. Hold on. So Z is up in Blender, but Z here is in the X. What I'm saying? Going up. Here's going left or whichever. But I should also remember that this is not actually, hold on. So what our camera is here? Our camera is 2 minus 2, 2, right? 2 minus 2, 2. And this is how it actually looks in 2 minus 2, 2. Is the cube scaled or something, or what? Or maybe the local focal length is different. Yeah, probably the focal length is different. Hold on. The focal length. The focal length, like FOV to focal length. Yeah. Bro, come on, is there no calculator? Like, come on. The heck? Fuck is that? If I knew the focal length, I wouldn't search. Bruh. Yeah, not a simple calculation, I see. So, damn it. Oh, there you go. Okay, so you just changed here. It was in front of me all this time. Alrighty. So now it's 70. And the camera right now, I want it to look at the 0. How do I do that? View or watch? Watch. Oh, yeah. Let's just go here. And let's focus on this somehow. How do you look into some object? View. Cameras, active camera. What? Center the view so that the cursor is in the middle of the view. So why didn't it work then? Align active camera to selected. Watch. Try this. Just hold on a second. I'm just trying to understand what's up with this. Hold on. What if I done this then? View camera. Line view. Center. View to cursor. What? This seems like a very old Blender. Constraints. Tracking. There you go. Track 2. Or what is it called? Yeah, track 2. Target is the cube. Oh, okay, let's go. That's what I'm talking about. And yeah, that's what I want. Now go to 0. But it still looks super big. So to target the cube, well, dimensions. Yeah, that's probably what I had, right? Yeah, but why it's dimensions too? So the positions that I was getting is like from -1 to 1. I see. But let's just go with dimensions 1, 1, 1, and let's actually object, apply, scale. Okay. Now that's essentially it, but yeah. Oops. So right now, is there a way to show like just like the position, kind of the UV or something like that? That's gonna be interesting. Theme world viewport. No idea. No idea. Okay, anyways, so 0, 0, and this is what we have. Right, we have the same camera, same everything basically. So yeah, it has like a material thing. Of course we're gonna make materials, but do I want to add it now though? Do I want to add it now? Should I add it now? For that we're also gonna need the light stuff. And yeah, I think for now I'm just gonna stop the stream until later on, and then we can like continue. Quite tired at this point, so you can see like the UVs. Yeah, how do you see the UVs? I don't think I want. I don't know. How do you see the UV? How to see Blender UV? Come on, I just want to see the damn UV, bruh. Not really what I want. Oh well, anyways, so oh, there's actually shaders here too. I don't think I can figure this out. Where's the output? Oh yeah, where's the material output here? Oh yeah, there you go. Alright. Here it's using the BSDF. I don't want that. I just want the UV map, I guess. Value, particle info, curves, color attribute. Oh, okay. So what I'm doing currently, I think I'm probably going with doesn't look right to me. Doesn't look right either. All color vector. What I'm doing? Yeah, no idea how this works. So, what about UV? What about UV? Add UV. Oops. Oops. Not really. I'm missing something. No. Yeah, nope. So yeah, that was it for this live stream. We pretty much added what is it called again? Yeah, we added depth attachments and we added matrices stuff. Though a lot of things are still very like hard coded, and we also don't have the model matrix just yet. Though that's pretty easy to add, and we also have to update the matrices every time the camera moves or the models changes or something like that. But yeah, that's pretty much it for this live stream. Hope you enjoyed it a bit. And see you in the next one. Have a good day or good night.